I just want to make sure we are in sync on kind of what stories we need to build. And my concern a little bit now is that we're getting ahead of in the Mac environment than Windows. I just want to make sure we're in sync on how we're building things. So Mike, do you want to share your screen and maybe talk us through? So. Yeah.
Okay, let me go over to this picture here. So, TP. So what I did was, let's go over a little. I created this block diagram, which is on the functional spec and your slides, and to identify all the pieces that we need to build in order to complete the Windows and Mac. And I separated it out a little bit differently than you did, a little more deep, smaller pieces, which I can explain. Like for example, we've got sort of this service layer where there are very thin API wrappers around the actual request. So you've got the authentication, client provisioning, you can see them all here. And then these stateful controller, these are meant to be stateless, very simple. You call it API, it may return some data. And then these stateful controllers here, which is where the business logic really lies. Different areas: authentication manager, provisioning, polling, probe, etc. Just you probably recognize all these. And from an architectural point of view, rather than using observer pattern, it's a pub sub pattern where each one of these, they communicate with each other essentially by publishing events with data and subscribing to events from others. So that's how basically they'll communicate. Typical pub sub type thing. Yeah. Yeah, I'm just giving kind of an overview, and then we can go to talk about the individual stuff. The UI, this was one of the other things we wanted to do. The UI is separated into a separate process here. And there's a IPC interface where the UI is just rendering what it receives in terms of UI state, JSON in a JSON encoded format. And there's messages that go back this way for example, if someone clicks a particular button or what have you. So that's kind of like the overview. And the idea being, break down all these pieces like this, and then create epics, and from epics, user stories for everything here, so that we can then plan exactly when all this will be complete. So there's another page here where we started to, basically take each one of those and put some notes here. I need to go through and add more detail to this, obviously, but there's a lot of little notes here that Eric has added on what these are meant to do and how, what the user story should look like coming out of them. But in my mind, the way I look at this is each one of these is sort of an epic, and then you have user stories to complete it. And then over here in this column, it's if we start from today, this is sprint number 1, just for example. Then the next sprint is sprint number 2. Then the next sprint is sprint number 3. It would just be trying to identify when these things would be complete. So you can see,
and those numbers are not realistic at this point.
Right. This is I just put numbers in there just for example, right? Just to,
yeah.
Obviously, it's not. I mean, I think we've got like 6-7 sprints before, or something like that. So we've got, but we've got to do Windows and Mac during those 7 sprints. But anyway, it's just so that's the concept. The concept is you know, break everything down into these pieces, and then from each one of those pieces, you have epics and user stories, and then we want to plan which one of the, you know, we want to plan the order and when which particular sprint these things are going to be done in. That way, we know, for example, that everything on the windows will be done by, say, sprint 6, or for example. But that's the idea. So we do that kind of planning. Make sure we've got. The goal is that in Jira we want to have epics and user stories. Well, at least we want the epics for everything that we're going to need, with nothing missing. We have those epics, and we know what sprint we're going to do those. We're going to complete that epic by. So at the very high level, we have all the epics, everything we're going to need, and what sprint they're going to be done in. Then, as we go along, or as soon as possible, we start creating user stories for those epics and just put them all in the backlog, groom them, and so that we always have a whole bunch of stories in the backlog ready to go, groomed for the next sprint. That kind of thing. So and then that way also we can look at Jira and we see all the epics and we know which sprint they're going to be completed in. And from a project level, we can say, okay, Windows is going to be done, at sprint number starting from now, 6 sprints from now. Mac will be done X number of sprints from now. So that's the idea. And then as far as the architectural details are concerned, I think breaking things down into smaller pieces, like having these stateless wrapper APIs, it makes it easier for unit testing, for one thing. Also, any OS dependencies can be hidden in here, although we're not intending this to be necessarily cross-platform, because we'll be doing it in C# or in Swift UI or Objective-C or whatever it ends up being. The conceptually, architecturally, each platform is the same, is done the same way. And I personally feel that a pub sub architecture is better than a lot of observables, just because it's easier. It's loose, that means that all these things are loosely coupled. It's just easier to deal with than if you have one for example, authentication manager observing 3 or 4 of these things, and then you need to go have him observe something else, and you have to go add that code. It's just a lot easier to just have pub sub, and it loosely couples everything. It's in my experience, it just makes the whole system easier to deal with. You have a lot of advantages. For example, unit testing, debugging is all easier. It's just something I personally prefer than over observables. So I know there's a lot talking about here. The other and also we want to make sure these are separate processes, right? Now this application process, this is actually a service, and this is the Windows service. So we want the Windows service to encompass, as a separate process from the UI, all the business logic here. And what I'm doing at the moment is this tunnel control service here is I'm creating an API, which is effectively a DLL, which has methods that the tunnel manager can call for, similar to what is done now, starting the tunnel, stopping the tunnel, adding an endpoint, very, very similar to what you had identified as all the APIs needed in the the Wireshark manager would call. These APIs are going to exist here, and you can start, modify, add a peer, which is add an aggregator, for example, set the IP address, get stats. But that is not it's not like it is now with the WireGuard tunnel service. It's a library that you call, and you can get return, data back from it. And it just has an API that you can call from C#, and it's not a service itself. We want the service to be all of this logic here in one service, and then we have a separate UI process. So there's a lot of detail to work out for this, but as far as this one's concerned, the one that I'm currently working on, I will fill in all the details to the user story by the next couple of days with the API. And then from that, for example, what the tunnel manager has to, and also the other thing is how these talk to each other. For example, the authentication manager, how it kicks off the provisioning, and the polling manager, and how these things get started. Based on your slides and based on the functional spec, I'd like to do a swim diagram, for example, because it's kind of hard to represent here, which I'm going to work on tomorrow morning, where you can look at it and see, the relationship authentication manager, how these are all interrelated in terms of what they're publishing and who's subscribed to what. And you can see it kind of, like a swim diagram is kind of like a state diagram, where you have multiple states for each one of these. So it'll be a swim diagram with lanes for each one of these guys, and the messages and how they go between them. So I think that will, and then we can. So I guess there's a couple of things we'll need to, discuss that, and discuss how you feel about this, and all these, and how you envision things yourself. So I know that's a lot, and we have a lot of stuff to discuss, but I just wanted to catch you up on where my thinking was.
Okay. First of all, I would like to share my idea that with the new architecture, we can resolve the one of the important feature mentioned in the FAD, that the timing profit. For example, like that, sometimes user can terminate the application, and if with my architecture building application with only one process, when user terminate the application, everything will stop. Different with that, we have your architecture design split application architecture into two process, a UI process and service process. That is it will have advantage that the user just work with the UI process only. Even though user terminate the UI process, our application, I mean that the background service is still working in the background. Okay.
I think, and since the UI process is started by the application process, he can monitor and restart it, right?
I personally, I happy with that that architecture, but there are something we need to discuss together. The first thing I would like to talk about the project timeline. Yeah, as you know that my team start working on the multiple platform, Windows, Mac OS, Android, and iOS platform. So when we get back the time when we provide the timeline to build up application on Mac and on Windows and Mac. We base on our architecture that at that time we had yet, and we provided about 6 months for the client side, including the Windows and Mac application. Yet I provide the detail, the stage, with the 4 stage. The first stage for implement the internal function. Yet, and the second stage we will integrate with the client with the server side. And the third stage, we start the end-to-end testing as well as the fixing bug. And the last stage, we will focus on the prop up the application. I mean that build up the installer as well as the bucket in order to upload on the cloud as well. Yeah. With the new architectures, I believe that with loss of experience, he looked at the current cost base, and I believe that he can understand right now our current cost base. I mean that our current architecture just support only one process. Yeah. And with the new architecture, we need to separate UI process and the background service. Yet, and I am afraid that if we change the architecture right now, it will affect to the project's timeline. So I would like to ask Chris about the impact.
Yes. Yeah. So I mean, we will have to have. I think that has been made clear by MCC. The only way to solve the tamper proofing was to have 2 different processes. So
also,
yeah, so we should evaluate. Yes, I mean I understand there could be an impact to the time schedule. So we should review this, and if we need to update the schedule, that's something we have to do. I'll do that once we go through this and scope each item.
TP, also let me point out, just like it currently, for example, the service that started at the moment, right, in the current Bitbucket branch, is the service that is started by the tunnel DLL, and it's not really our app. The application. The service control is wrapped around the tunnel. In other words, start the service starts the tunnel, stop the service stops the tunnel. The service is associated with the tunnel, which was from the demo code, which is good for demo, but that all has to be changed anyway. So it's definitely going to stretch the timeline for sure to have the separate UI process, because that's a whole nother thing to deal with. But obviously that was all going to have to change anyway, because that couldn't go into production like that. Yeah, I mean, I understand what you're saying. It definitely is going to affect the timeline to do this for sure, but there's not much that's been done yet. So it's
well, I think TP's team has done a lot, but I think it's more individual researches, right?
Yes, no, that way. Yes, you've done a lot, but I mean, in terms of what the final product would look like, you still would have to fix that. That still has to be. There was some architecture work that needed to be done anyway, right? You couldn't just leave that service connected to the tunnel DLL, and so all that was going to have to change anyway.
Okay, I think that we will discuss about the timeline later, and because I would like to ask some another question. Yeah, as you know that the MPA as well as the TS will run on multiple platforms. So I would like to ask about the new architecture. It would be work well on the platform. For example, like that, I just know iOS. It look like that they are not separate process.
No, that would on mobile device, it would be one process. Yes.
Yeah.
So.
And I would like to ask about the stateless service. Stateless service. Did you mean that this service will develop by one time and can reuse for multiple platforms?
Well, I mean, ideally, so this
no, short answer is no, but now explain, Mike.
Yeah. So no, we're not going to. It's not cross-platform in terms of the actual code. It's just we want to have the same conceptual architecture.
Yeah. Okay.
Okay. Right. Now,
okay.
I mean, if we have more, I'm really, this is a difficult one for me because I would intuitively, I would make this cross-platform from the beginning, or for desktop at least, and iOS. But that would probably, I think, slow things down at the moment, because we probably, or maybe not. I don't know. I'm still on the fence about it. I mean, it's just that there's a lot of code that's already been written that can, it's going to be used, I suppose.
Yeah, I think, Mike, that will be a later discussion, right? But our goal, what we promised for this year is Windows. The stretch goal is Mac OS, right? And any mobile devices are next year. So if we make a compromise, we have to get Windows complete, right? We have developers who can do Mac OS in parallel, but the main focus is to complete Windows. So I'm not sure, Tip, if you found another candidate, but I think Mike and we have and Mike P, right, are working on the Windows side. If we get another person, we'll have 4 people, and then we'll have I guess 2 developers on iOS, or 2 or 3, right? So hopefully Windows will run faster, and then we can design this and create the APIs and everything, or the pub/sub message structures, and then we can just make sure we use the same structures on the different platforms, and then it would be very easy for somebody to move in between, if nothing else, right? It's the same flows, the same components, and also troubleshooting, etc. I think will be fairly simple with this pub/sub. What I've seen in the previous company is that we logged every message, and then you could replay. You could replay a message and get into the same state if there was a timing issue, etc. Right? So there's a bunch of benefits I think we can leverage, even if we don't use the same. Even if, and we could write this, I think, Mike, you're saying C++ or in Go or something, right? And make it cross-platform, but let's not do that today.
Yeah, I know. That's why I said I'm so tempted to want to go that route, but I think it would slow us down for getting Windows out.
Yeah, and I think the skill set of developers and stuff would maybe be ramp up the curve, and you said rewrite a bunch of code, because I think there's a bunch of code written here for polling manager. I think even posture check, which we don't need yet, right? So there's a bunch of code that we can reuse, and it maybe a split out and a cleaner separation.
So no, I agree. We just but as you said, because if we using the same architecture on all the products will make it easier to go from work on one and then the other, and debugging, troubleshooting, etc. So the way I would normally approach this would be.
Okay. Sorry, I need to drop, guys. Sorry, but please continue.
Yeah.
Okay. Sorry about that.
So TP, the way I would normally approach this would be to create epics, for everything. Each one of these components, every single thing here, and then go through and just at a very high level, try to break down what that particular component has to do, and then just very, very high level, some very high level user stories with it, so that then we could say, okay, we can have these three components done, we'll do, and then determine the order. Okay, we'll do this, then this, then this, then this. So the question I have, or the thing is, and we started doing this here, right? Just started, putting some detail about what needs to be done. But there obviously, I'm going to go through and fill in as much of this that I can think of. But I'm wondering when can we get together to discuss details about this, because your meetings, your engineering meetings are.
Yeah. Let I share a little bit about the current status. Yeah. I think someone in the Sotel can talk with you that when we start prototype, I mean that the start MPA projects, that the second phase of the MPA for the client. I mean that need the application installed on the platform. It is different with the browser based. The first phase developed by the Menlo in the US and India. Yeah.
Yes.
The first phase just focus on the MPA only for the web only. Yeah, I mean that's the browser based. Yeah, and when TeamLeader started for let me remember exactly the September last year. Yeah, and the India team were still working on the phase one. Yeah, and TeamLeader side start look at the solution for the VPN solution. Yet, and I already updated with you that there are some open source solution we spend time to investigate. Yet, and finally we choose the WireGuard solution. Yeah.
Right.
And so I would like update the current status for the client side and the server side. Right now, the server side is still implementing the server side features parallel with the client side features. Yeah, so you can see that there are some feature like the propping. The India team implement, and the client side implementing as well. Yet, so it is very hard to tell that implementing for the propping manager or the propping service done or not done. I mean that I cannot we cannot identify that implementing at the client side done if not testing with the server side. Are you can you understand?
Yes. No. I know that she's gonna. Yes. Okay.
Yeah,
The server. server's not done yet,
Yeah.
right?
So I just share up my idea that it's very hard to comment that the epic or the any features done or not done. Yeah. Right.
No, yeah, no, I understand, but I think that it's going to be very challenging. But I think what can do is identify, you know, we have a pretty good idea of what all the different components are supposed to be doing. And even though, for example, you can't, um, you know, you can't actually query. This is where you know, unit testing can help. Is because we know, for example, what the probe service is supposed to be able to do, or what the probe manager is going to be, or yeah, we know what it's supposed to be doing according to the functional spec. And so we can at least, you know, code or define, you know, how it's going to function. You know, like for example, the messages between these guys. We know that it's got to make certain calls into a probe service, or if that's what we want to do. And we know that that probe service, although if it's not working, we know what it's going to return something. It may not be, we may not be able to return exactly what it's going to return until it's done, but we have a fairly good idea in general. We can put stubs in. So, you know, we can stub all the stuff out that's not actually working on the server side. We can put, you know, basically stubs in there, fixtures, for example, right? So we can have fixtures for the probe service, fixtures for provisioning, even authentication. We could do, you know, mock something up on this for the, so there's no, maybe there's no server over here, but we can proceed with identifying, you know, the different states and the different, you know, functions that this is going to have to call, what it might expect back, you know, how the threads are going to run, how the timers are going to run, things like that. You know, yeah, I hear what you're saying. We can't actually get, without having the server working, yeah, it's not going to be it's not going to be accurate down, you know, to that level, but we can still proceed with it and get it, you know, get pretty close to what, to, you know, I think we get pretty close in the planning. If it goes, you know, if we say, okay, it's going to take so much time to do this and this, we do it, you know, next sprint, and then we get there and the server guys haven't done it yet, or they run into problems and it takes longer. You know, we just have to adjust as we go, right? Just, but we have to have just some kind of a feel in greater detail than we have now. I know it's not going to be 100% accurate. I realize that, but what we do need is, we need to just, if nothing else, create placeholder epics for everything. And, you know, just if we work backwards from when the date is, we know that we have to have windows done by a certain date. We can put dates onto these epics, like, okay, this epic has to be done by this sprint, this epic by this sprint, and this epic by this sprint. Then as we go along, if you know, things are slipping, then we can deal with it as we go. But just give us, you know, a ballpark, you know, figure for an order for how things are going to be done. If the server team is not ready to do something, then, you know, we can do something else, or we can mock it up with some fixtures and unit tests, you know, that sort of thing.
Mm. Okay.
What is the status now as far as the server and where are they? Is there an authentication service working yet?
Not yet now. Yet.
Is there a provisioning service at all?
No, there are lots of enhancement from the Lion team and the back end team. Yet, right now I can update with you that only the logging service that is not dependency from our external service, and the client application can develop and testing only logging feature.
Yeah, I understand. It's not.
Yeah.
Tricky.
I can say a little bit the trust network, because the trust network that is the feature, the device, I mean that the client application run on the personal device will check with the check if it can be it can reach to dedicated server like the HTTP server or the ping server. Yet that with that feature of the trust network, our team can set up the server to repair for implementing the trust network feature. Yet I mean that the trust network feature is not dependent on the other team, so the client team can handle that. Yeah, but the remaining feature as well, for example, authentication, propping, client provisioning, we definitely depend on the service provided by the other team. Yeah.
Right. Okay. So I think the thing we probably have to do then is set up a system where we can use internally some fixtures for that, which will return the data that we expect, so that we can just get the application logic running. And even though there's no server, obviously when the server does come, then things will change and it could be different, but we should okay. I think I want to. I think what I'll do is I'll spend some time investigating how we can implement some fixtures to stub out those services, because we don't know when they're going to be ready. And yeah, okay. So and obviously that may change. So for example, this client provisioning service, let's say that we don't know, like, okay, so it's not working now, and we don't know if it's going to be, we don't know if it's going to be JSON, or we don't know if it's going to be protobuf, right? For example. So we can't really write this at the moment, but what we can do is we can create, a service which is basically returning a fixture, or returns a class of data, which we know needs to be, based on the functional spec, at least close to what the data is expected to come, so that then the provisioning manager can pass that off to probe manager. Probe manager can, again, the probe service can just be stubbed out and return a fixture of something that we expect, so they can then go and tell the tunnel manager to start the tunnel, something like that. But we should be able to get at least the message passing, the pub sub, have these talking to each other in the way we think they should talk out using just stubs here for these services.
Okay. No, I just remember that, and I would like to ask you, the service, I mean that the stateless service, that is the DLL.
Well, it doesn't. No, not doesn't have to be. I suppose it could be.
And
eh,
I would like to ask, this service will run in the separate thread.
Well, no. With the way I envision the stateless services is these themselves are just, you can think of them as just classes,
Okay.
functions that you call them,
Okay.
and they would.
Yeah.
Now,
Right now, we implementing the current cost like that. Yet,
yeah.
but
So
we don't split out the manager and service. Yeah.
right. So the managers would have separate threads if they need them, right? These can be separate threads if that's necessary. But there would not be any separate threads here. These are just classes that get called. They're just thin wrappers. Like, for example, client provisioning, for example. This client provisioning service would just be a wrapper that provisioning manager can call it. And then this would then go do the HTTP request. It would parse either the JSON or protobuf, whatever's used, and it would return a data structure to the provisioning manager. So the provisioning manager calls it, gets the data structure back. And but if the provisioning manager needed to be a thread, he can be a thread in here. This itself is just a very thin, it's just a class wrapper. It could be in a separate DLL if you want, but it doesn't have to be. I mean, this doesn't really matter. It's just a class. Maybe. So that's the idea behind these stateless services. They're just very, very thin APIs around the network, the service that's being provided by the servers or by some function, right? Like, the tunnel control service, for example, is doing all the IOCTLs and the various manipulating the Windows firewall, all the things it has to do when tunnel manager says, you need to create this interface, you need to start this tunnel, it goes and does all this other stuff. It itself doesn't have any threads in it. It's just now this will actually be a separate DLL, but that's because it's just easier to do it that way. But they don't have to be separate DLLs. It's just implementation detail. If it works out, I mean, if it's better to do it that way, then yes. But it's
personally, I have my idea that from experience that event broker, I mean that the pops up design pattern very popular with the client side, whereas there are lots of services, lots of application need to receive the event from other service. Yet, but with the client application architecture pops up is less popular than the observer. Yet observer is used more than, because it as you know that the scope of the client application is very small when comparing with the system at the server side. And in a client application, there are some thread and some instant of class. Yeah, and these the instance can communicate each other, and I think that's observable is used more than the pops up the pattern. Yeah, that is just that is just my my experience on design pattern. Yeah.
Yeah. No, I understand. Yes, absolutely. A lot of people are used to using the observables,
Yeah.
but just in, yes, this is a very the client. This particular client at the moment is fairly simple. Right?
Yeah.
Not a lot of states, you know, and so yeah, pub sub may seem like overkill, right? For this simple, very simple client.
Yeah.
Very simple.
For
But
some complicated system server at the server side, most of application deploy the separate event broker like the Kafka, Reddit, RabbitQ on the dedicated server. Yeah.
Yes, but this is conceptually like that, but it's not. It's not. This is nothing. This event broker is not. That's just that's just what I've labeled it as, because that's what it does. But it's not doing anything like that. All you need is a class that exposes a publish and a subscribe.
Yeah.
And then on the publish, when someone publishes something, when someone subscribes, when some other entity, some manager subscribes to it, it keeps it in a list. And then when something gets published, it goes through and it just, you know, passes the event to all the people subscribed for that event. It's very, very simple. It's nothing like Kafka or RabbitMQ, nothing like that. It's just very trivial. It's very trivial. It's a very simple class. This is very simple.
Yeah.
But it's not, you know, it's very simple to do. So, but I understand what you're saying on the server. This pattern was made popular on servers, but it works well on a client because it separates everything. The observers, and yes, this client's pretty simple. So, you know, you could do it with observables very easily, but the pub sub just gives you know, an easier thing to maintain as the complexity of this thing grows. It'll be much simpler to modify and to debug down the road once things start to get complex and we start running into corner cases, and you know, it'll be much easier to deal with than having to add observables to everything everywhere. If it turns out that, you know, that happens. Anyway, but no, I wouldn't suggest this to be an event broker like Kafka or anything like that. This is a very simple class with some publish and subscribe. It's very, very simple. You know, this is not, you know, and clients, the pub sub pattern is pretty popular for web applications now on the client side.
Yeah. Because there are some framework like React and Angular. They integrate the Redux the Redux library to support the pop-up event. Yeah.
Yeah, and so Rita, yeah, so this would be similar to that in, you know, except it's far simpler.
Yeah.
You know, it's just very, very simple pub sub. It's not using anything like Redux. It's far simpler. It's very, very simple message passing amongst these managers. So, but I think the next step, okay, what I'm going to do is go through and add a lot more detail to all these things based on your slides and your specification and the functional spec, and just try to put it where I think it goes and investigate this problem of fixtures we're going to need, because we don't have servers, so that we can at least get an idea of how long everything's going to take. But, code up as much as can be done with fixtures on this side using fixtures. I think that's how we're going to have to go.
Okay.
Because the data, I don't know, a lot. Yeah, we'll just have to make sure that the data being returned is similar enough to what the server is really going to return, so that when the server is actually working and ready, we don't have to make a lot of changes. That's the way. But I understand what you're saying about the server not being ready. That poses a problem.
Yeah.
So
Right now, until now, we have some prototype. I mean that we had to check the solution, like the VPN selection, and right now, as you know, we have the chain in the JSON, from the JSON to the protocol buffer. Yeah, that is the serialized solution of the Google support for transfer data between the client and server over any protocol. Yeah, and we have the ticket to do the prototype on that. Make sure protocol buffer can work well can work well with the different language programming language. Yeah.
Yeah, it works fine.
And that is a good time for developer to learn and familiar with that. Yeah.
Yeah. Protobufs work well with all languages. They're pretty popular. What I would suggest is that all that protobuf is hidden. So for example, right? Let's say the client provisioning service is using protobufs with HTTP.
Yeah.
We would want the provisioning manager to call a class, a method on, this client provisioning service, just for example, would be a class that exposes a method for the manager to call.
Yeah.
And inside this provisioning service, it would do the HTTP request and decode all the protobuf, deserialize it into a data class. And that data class would be returned to the provisioning manager. And by the way, the Google has code generators, which will create all the stubs for the classes to decode all the protobufs. So you define it in a proto file. Then you run the part of the build system. You run it generates the code for you, and so then your classes in here can use that code for decoding data. And anyway, and then they would return that. So the protobuf is all hidden from these guys. They don't know anything. They don't care about protobufs. They get a data class back. They can do, and since C# has support for things like asynchronous programming, like await, this can call into here.
Yeah.
And it can do, and inside it can be doing an await to go network, get the response, code it, and then send it back.
Synchronous very popular with the web application.
Very similar to like Java.
Yes, Java just support one thread.
So
JavaScript.
Yeah, so this guy himself, you can have lots of threads here, right? Yeah. But this particular thread can be calling in here, and inside he can do an await. So this thread is just waiting, basically. The await, the await function. So I think C# has that now. So That's so that way you don't have to have. It can appear to be synchronous even though it's not synchronous from the provisioning manager's point of view. Anyway, all the protobuf stuff can be hidden inside here. The provisioning manager doesn't need to worry about it. It just gets its data back. The client provisioning service itself, that class can handle the protobuf, the HTTP request, all that stuff. Anyway, as an example. But yeah, it would be good to become familiar with that protobuf, how you generate the classes as part of the build system, how you use them, you know, obviously, a little bit of figuring out. But yeah, anyway, so what about this morning, the morning meeting?
The morning
The-
meeting with
Yeah.
Eric. I and Eric just seen up in the case there any news requirement from the other team like the marketing team or the or design team. Yeah, and I update with him a little bit about the current status. Yeah,
But
not so important.
yeah, no, the other one, the one that's with the server, the client engineering meeting.
For the meeting on Monday on Monday, because
This one.
yet because this month I have some personal affairs overlap from the 6 p.m. to 9 p.m. So I plan that started from next month. I can change my my calendar and agree with the timeline suggested by the PD. Started from 7 a.m. to 8 a.m. at your site. Similarly, at that time, that is 7 p.m. to the 8 p.m. I and some key member in the team, I can join that meeting. Yeah.
So that's starting from next month?
Next month, yeah.
Okay, all right. Now I just want to make good. So you'll send it, you'll let me know whenever that is. Okay. Yeah, good. Perfect.
Okay, thank you for sharing the new architecture for the client side. In short, there are some advantage like that. We split out the stateful. I mean that the status of application, separate out the service handling the behavior. Yet, and we in the new architecture has used the pop-up design pattern replay for the observable. Yeah, and the big change is that we split out to process on the desktop platform, the UI process and background service process. Yeah, I'm happy to get this information.
Okay,
yeah. But as you know that get back the first my concern that could be impact on the timeline. Right now I get that I and you cannot make the decision because the right person is marketing team because they had a deal. They had the discussion with some potential customer. Yeah.
Okay. No, sounds good. All right.
Yeah. Hopefully we can get the update from Eric related to the if we can change we can we can extend the timeline when we apply the new architecture. Yeah, that is my very big concern right now.
Yeah, I understand. Yeah.
And
All right.
another risky with our estimation was server side and client side implementation parallelly. And sometimes they are changed at the server side. That impact on the implementation of the client side. Yeah. That were risky when we provide estimation, high level estimation. Yeah.
Yeah. No, I understand. Okay, it's going to be a lot of challenges in there. All right. Well, we'll see what happens there, as far as scheduling. Okay. Well, I guess I will speak to you later.
Yeah.
Okay. All right. Thanks very much, TB.
Yeah.
Okay.
Thank you, Mike.
Bye-bye.
Bye bye.
Bye.